You know that feeling, right? When you're chatting with a bot online. Sometimes it's uncanny, like it just gets you perfect answer straight away.
And other times.
Yeah, other times it's that classic, I didn't understand that. Or maybe worse, something totally off the wall. It's pretty frustrating.
Oh, definitely. Almost everyone's hit that wall.
Yeah.
And that inconsistency, it really shines a light on the engineering challenges behind the scenes, how these things are actually put together.
Exactly. And that's what we're digging into today in this deep dive. We've got this stack of source material articles, some research notes, and we want to unpack how chatbot building has evolved.
Hmm.
Our mission really is to understand the core challenge and the clever solutions when you try merging those, older, reliable methods with this incredibly powerful new AI, like large language models.
Yeah, because there's this fundamental tension, isn't there? Do you stick with handcrafting everything for total control? Or do you let the AI generate answers to get speed and scale?
What's the trade-off? What do you gain? What do you lose? Okay, so let's start unpacking that. How did things used to work? Let's call it the old way.
Right. So before the whole generative AI explosion we're seeing now, building a decent chatbot was uh, pretty painstaking. It was all centered around training. You had to train the system to understand natural language using things called classifiers.
Okay, classifiers. So if I were building a bot for a bank, say, I have to guess the common questions.
Precisely. You'd anticipate what users might ask. So if you thought people would ask about opening hours, you define an intent. That's basically the user's goal, right?
Gotcha.
So things like, what time do you open? Or maybe, when do you close?
Hmm.
They'd all get trained to point to an hour's intent.
And something like, how do I open an account would be a different one, an account intent.
Exactly that. And you'd feed the system loads and loads of different ways people might phrase those questions, example sentences.
So the classifier learns to recognize the underlying meaning, the intent.
Yes. And here's the really critical part of that old method. Once the bot recognized that intent, you had, like, absolute pinpoint control over the exact response it gave.
Okay, so for the hours intent.
You could write the specific text. We are open from 8 a.m. to 8 p.m. every day, period.
And the bot would always say exactly that, no variation.
Always. If it nailed the hour's intent, it delivered that precise pre-written text. This gave builders incredible control, especially for really critical information.
Yeah, I can see that. You could guarantee the branding or legal bits or specific numbers were spot on every single time.
Total control, which for important stuff makes a whole lot of sense.
Okay. Now, you mentioned the kinds of questions people ask. This idea of a long tail comes up in the
Oh,
sources.
yes, the long tail.
Yeah.
So imagine plotting out all the possible questions a user might ask on a graph.
Okay.
At the very top, the head of the curve, you've got a handful of questions that get asked all the time. Super frequent, like hours or opening an account.
The greatest hits?
Exactly. But then the curve drops off really sharply and stretches out into this long, long tail. And that tail is full of questions that are asked very, very rarely.
Like my crazy example, how do I use my gold card rewards points when I'm booking a multi-city international trip through a third-party travel site?
Perfect example. It's a totally valid question,
Right.
right? But maybe you only see that one specific query once a year, maybe less.
Okay.
Now, with that old classifier method, you technically had to train specific intents for all of those questions, even the super rare ones in the tail.
Oof, that sounds hard. Training for the common ones at the top, that seems manageable.
It was. But as you move down that tail,
It got tougher.
immensely cover. Trying to train intents for those really infrequent questions, it became incredibly inefficient. You needed lots of different example phrases for questions you almost never saw.
Right.
So you'd quickly hit this point of diminishing returns. The effort to train just one more obscure intent was huge, and the chances of the bot actually getting it right were pretty low.
So what did that mean for the poor user trying to ask that obscure question? What was the experience?
Well, that's where the frustration we talked about earlier really kicked in. Past that point of diminishing returns, the bot just couldn't recognize the intent for those long-tail questions.
So it defaults to,
Either the generic, sorry, I didn't understand that, or sometimes worse, it would guess wrong, misinterpret the question completely, and give an irrelevant or incorrect answer. Yeah, it created this really rigid, kind of brittle experience. It worked okay for the top 10 questions, maybe, but failed users on pretty much anything outside that narrow scope.
So the old way gave you amazing control for the common stuff, but just couldn't scale. It couldn't handle the sheer variety, the messy reality of all the questions people actually
It
ask.
couldn't scale at all,
Okay.
really. And this is precisely where generative AI, especially large language models, LLMs, suddenly appeared,
Mm.
promising to solve that exact scalability problem.
Okay, the new way. How did generative AI propose to, speed things up and actually cover that whole long tail?
The core idea was a big shift. Instead of predefining every single intent and writing every response, it moved to a much more dynamic approach, often using a technique called Retrieval-Augmented Generation, or AG.
Argy. Okay, I saw that in the sources. So how does RAG work? How does it change the game?
Well, instead of trying to pigeonhole a user's question into a predefined intent category,
Like hours or account.
exactly. Instead of that, the RAG pattern works more like uh, an intelligent search engine combined with the summarizer.
Interesting.
So user asks something, the system takes that question and uses it to search through a big pile of documents, could be FAQs, manuals, website pages, product info, internal notes, whatever knowledge the company has.
It's basically searching its own library for relevant info.
That's the retrieval part, yeah. Finding those chunks of text, those documents that seem relevant to the question.
Okay, it finds some stuff, then what?
Then it takes those retrieved documents and the original user question, bundles them up, and sends them off to an LLM, a large language model.
And the LLM does the augmented generation bit.
You got it. The LLM uses the context it got from those retrieved documents, that's the augmented part, to generate a fresh natural language answer. That's the generation.
Huh. So the massive difference here is you're not meticulously training intents and crafting responses one by one.
Not in the same way, no.
Yeah.
You're basically feeding the system knowledge, the documents, and letting the LLM figure out how to answer questions based on what it finds in that knowledge.
Wow, that sounds, almost too simple compared to the old way. Just point it at your FAQs and manuals.
Well, it's a simplified view, but yeah, that's the gist. The complexity kind of shifts.
Yeah.
According to the sources, instead of managing hundreds, maybe thousands of intents.
Which sounds like a nightmare.
Right. Instead of that, you're mainly focusing on tuning two key things. First, the retrieval system, making sure it actually finds the right documents reliably. Garbage in, garbage out. Right.
Makes sense.
And second, tuning the generation system, getting the LLM to summarize accurately, stay on topic, be helpful, not make stuff up.
Okay. And the huge advantage, the payoff of this RAG approach.
It handles that long tail beautifully. Remember your gold card overseas question.
Yeah.
With Rang, it doesn't really matter if the system's never seen that exact question
Mhm.
before. If the information about using gold cards overseas exists somewhere in that document repository.
The retrieval part should find it.
Hopefully, yes. The retrieval system finds the relevant text, passes it to the LLM, and the LLM can generate an answer based on that text. So you get this incredibly broad coverage across potentially millions of different questions without needing specific training for every single one.
Okay, that sounds powerful. RAG gives you the scale and the coverage for that long tail, the stuff the old way just couldn't handle. But I'm sensing a but coming. This isn't the magic bullet, is it? This brings us back to that trade-off you mentioned.
Exactly right. There's always a trade-off. While ARIG is fantastic for breadth, for coverage, you absolutely lose that precise granular control over the output that you had with the old handcrafted responses.
So back to my simple hours example.
Perfect example. With RAG, even if your internal document clearly states, we are open 8 a.m. to 8 p.m. daily, the LLM, when it generates its response, might phrase it slightly differently.
How so?
It could say, our opening hours are from 8 a.m. to 8 p.m. each day. Or maybe you can visit us between 8 in the morning and 8 in the evening, 7 days a week. Or something else entirely.
Okay. It gets the core information across, but it's not the exact wording I wrote. Why is that necessarily a problem if the meaning is still correct?
Because for those really common, really critical questions, the ones right at the top of the long tail, the ones people ask constantly, that precise wording often matters a lot.
Like for legal reasons or
Right.
branding.
Exactly. Think about compliance statements,
Mm-hmm.
specific legal disclaimers, maybe very precise pricing information, crucial brand messaging points, or maybe a critical safety warning. For those things, you need to know with 100% certainty that the user is getting the exact pre-approved text.
And relying on an LLM to rephrase it even slightly introduces a variable, or WUSC, maybe.
Precisely. It introduces uncertainty right where you probably want, at least in your most frequent and most important interactions.
Okay, so we're kind of stuck then. The old way. Great control, but it breaks on the long tail. The new RAG way. Fantastic on the long tail. Scales well, but you lose that crucial control for the common, important stuff. How do you solve that puzzle?
This is where the really smart approach comes in, the one highlighted in the sources. The hybrid solution. It's all about strategically blending the best of both worlds.
A hybrid. Okay, tell me how that works. How does the bot decide which system, which method to use for any given question?
So when a user asks a question, the hybrid system makes a decision first. It checks. Is this question one we recognize? Is it one of those super frequent known questions? Does it look like something from the very top of that long tail curve that we know people ask all the time?
So it's like it checks, is this the hours question or the open account question?
Basically, yes.
Mm-hmm.
If the system identifies it as one of those known high-frequency queries, it defaults to the old method. It maps the question straight to its predefined intent and instantly serves up that carefully crafted exact response you wrote way back when. The sources talk about it like using an internal cache.
A cache, like a quick lookup for answers you already know cold.
Exactly.
Ooh.
So for all the common stuff, it's super fast, super efficient, and you get that guaranteed precision. And crucially, it completely bypasses the whole RAG process, the search, the LLM call.
Which saves time and probably money, right? Fewer LLM calls.
Definitely saves resources, time, tokens, inference cost. You're serving the bulk of your queries, the most common ones, with maximum speed and perfect control.
Okay, that handles the common stuff. But what if the question isn't in that cache? What if it is my obscure gold card overseas question from the long tail?
Uh-huh. Well, in that case, the system recognizes, okay, this isn't one of our frequent pre-configured questions, it doesn't have a cached answer. Then and only then, it switches gears and activates the RAG pattern.
So then it does the search.
Then it uses the user's question to search the document repository, pulls back the relevant info it finds, ships that context off to the LLM, and the LLM generates the answer based on those retrieved documents, just like we discussed before.
Okay, so the hybrid approach. It's like having two tools in your toolbox. You've got the old, reliable hammer, the precise, controlled response for the common nails you hit all the time.
Yeah.
And then you've got the new, flexible, powerful drill, the RH system for everything else, all the weird screws and unexpected situations.
That's a fantastic analogy. I like that. You get the speed and precision for the everyday tasks by hitting that cache of predefined answers.
Right.
And then you get the broad coverage, the scalability to handle basically the entire rest of the long tail, all those rare, unusual, or totally unexpected questions using the RH mechanism.
And this completely sidesteps that diminishing returns nightmare from the old way, doesn't it? Where training for the long tail just became impossible.
Yeah. Totally avoids it.
Yeah.
You don't need to train specific intents for every obscure question anymore because the RA side can handle them generatively, provided the knowledge exists somewhere.
And by handling the frequent questions with the fast, controlled method,
You improve the user experience dramatically for the interactions people have most often. You guarantee speed and accuracy on common tasks. It's really about smartly leveraging the strengths of both approaches to build something much more robust, much more efficient, and ultimately much more helpful.
So let's bring this back around. For you listening, why does this technical detail, this hybrid architecture stuff, actually matter? Why should you care about how chatbots are put together?
Well, because understanding this balance, this strategic mix of controlled, precise answers for the known stuff and flexible generative AI for exploring the unknown knowledge base. It's pretty fundamental. Fundamental to building or deploying or even just interacting effectively with conversational AI today. When you encounter a bot that feels genuinely helpful, that can answer your simple question instantly and make a good attempt at your weird, complex one, chances are there's some version of this hybrid thinking working behind the curtain.
It really shows that the most effective systems aren't usually built by just like throwing the latest shiny tech, the LLM, at absolutely everything.
No, it's about smart design. It's about recognizing where precision is absolutely critical and where flexibility and broad coverage are more important, and then combining those approaches intelligently.
All to create that seamless experience that hopefully actually delights users by handling whatever they throw at it quickly and effectively, whether it's asking about opening hours or, that gold card question.
So yeah, we've traced this journey, haven't we? From those early, quite rigid controlled chatbots.
Limited, yeah.
Limited, explored the huge potential, but also the control pitfalls of purely generative AI.
Yeah.
And now we've landed on this rather elegant hybrid solution that seems to capture the best of both eras.
And the key takeaway, the core insight, it really feels like it's about finding that sweet spot, that balance. The best systems use the speed and control of the old ways for the questions they know are coming.
The predictable stuff.
Right. And they unleash the power, the broad coverage, the adaptability of the new generative methods for everything else, for the unexpected.
And, stepping back a bit, this whole idea of a hybrid system, relying on a fast, controlled cache for the common known situations, and then switching to a more exploratory generative approach for the novel or the rare, that pattern isn't just about chatbots, is it?
Ooh, that's an interesting thought to leave folks with. Where else might we see this kind of pattern, this balancing act between exploiting known, reliable methods and exploring new, unknown territory using more flexible generative power?
Hmm. What does it tell us, maybe more broadly, about how complex systems, artificial systems, maybe even natural ones, learn to cope? How they respond effectively to both the predictable patterns and the surprising curveballs the world throws at them?
Yeah. But something to chew on. It feels like a fundamental pattern worth looking out for.